Hey beautiful people, my name's Liesel and today we are learning about the atom. Since the dawn of time, people have wondered about the world around them and what it was made of. There is still lots to discover about atoms, and what we know so far is just a drop in the bucket. The model that we are going to use to present the atom is called the Bohr model. There are different models, but this one helps us to understand the atom better. Atoms do not really look like this. Atoms consist of three subatomic particles. First of these are electrons. Electrons are negatively charged. Protons. Protons are positively charged. These charges simply show that protons and electrons are opposites. The last particles are called neutrons. Neutrons are so called because they have no charge. So let's draw some Bohr models. First we will have a look at hydrogen. Hydrogen has the symbol of capital H. When we draw a Bohr model, we must remember that an atom has a central part, shown in yellow here, called a nucleus. Surrounding the nucleus are energy levels. In this case, we have indicated two of them, but there can be many more. When we look at the symbol of an element on a simple periodic table, we will see two numbers. Remember that most periodic tables have a key to tell you exactly what each number means. The smallest of the two numbers, usually shown at the top, is called the atomic number and tells us how many protons are in the atom. The larger of the two numbers, usually shown at the bottom, is called the mass number or atomic mass number. This number tells us how many things are inside the nucleus of the atom. This number is often rounded off to a whole number. Because the atomic number, the top number, is 1, we add 1 proton to the nucleus. Now let's look at the mass number. This number tells us how many things are inside the nucleus. In this case, 1. There is already one thing inside the nucleus, so we can just leave it that way. Now, if we look at the atomic number again, we see that a neutral atom of hydrogen has 1 proton and therefore 1 electron. That is because neutral atoms have the same number of electrons as protons. So let's add an electron. So we can see that if we have a neutral atom, the atomic number can also indicate the number of electrons in a certain atom. We add the first electron to the first energy level. It was helium. Helium, element number 2. Because helium is element number 2, it has an atomic number of 2. That means there are 2 protons in the nucleus. Helium has a mass number of 4. That means there should be 4 things inside the nucleus. We already have 2 protons in the nucleus, therefore we need to add 2 neutrons into the nucleus to make 4 things. Now we need to add the electrons. Remember, the atomic number is 2. And because we are dealing with neutral atoms, we know that we will have the same number of electrons. We can add these 2 electrons to the first energy level. Now this energy level is full. Even if we had a quadrillion zillion electrons, we cannot add any more to this energy level. That's helium done.
Lithium, element number 3. Lithium has an atomic number of 3. That means 3 protons inside the nucleus. Lithium has a mass number of 7. That means that there are 7 things or nucleons inside the nucleus. Since there are already 3 things, the protons, inside the nucleus, we need to add another 4 things, 4 neutrons. Now we have 7 nucleons inside the nucleus. Now, when we look at the atomic number again, we can deduce that there are also 3 electrons in a neutral lithium atom. Since the first energy level can only accept 2 electrons, we will have to add the third electron to the second energy level. The second energy level can take up to 8 electrons before it is full. There you go, and that is lithium done.
Brotherhood.
Beryllium, element 4. Beryllium has an atomic number of 4. Therefore, we have to add 4 protons. Beryllium has a mass number of 9. Therefore, we know that the nucleus consists of 9 nucleons. We already added 4 protons, so 9 minus 4 gives us 5. We need to add 5 neutrons in order to have 9 nucleons inside of the nucleus. Now we have 9 nucleons inside of the nucleus. Now let's look at the atomic number again. In a neutral beryllium atom, there will be 4 electrons. We must remember that the first energy level can only accept a maximum of 2 electrons. So 1, 2. Now we go to the next level. 3, 4. Beryllium's done.
Boron!
Element number 5. Boron. Boron has an atomic number of 5. That means that a boron atom has 5 protons inside its nucleus. Boron has a mass number of 11, meaning that the nucleus has 11 nucleons. 11 minus 5 is 6. We will add 6 neutrons. Now the nucleus has 11 nucleons, consisting of 6 neutrons and 5 protons. Let's look at the atomic number again. In a neutral boron atom, there will be 5 electrons. Let's add them. 1, 2. Now the first energy level is full. We have to add the next one to the second energy level. 3, 4. 5. Boron is done. Element number 6. Carbon. Carbon has an atomic number of 6. That means that a carbon atom has 6 protons inside its nucleus. 1, 2, 3, 4, 5, 6. Carbon has a mass number of 12, meaning that the nucleus has 12 nucleons. 12 minus 6 is 6. We will add 6 neutrons. 1, 2, 3, 4, 5, 6. Now the nucleus has 12 nucleons, consisting of 6 neutrons and 6 protons. Let's look at the atomic number again. In a neutral carbon atom, there will be 6 electrons. Let's add them. 1, 2. Now the first energy level is full. We have to add the next one to the second energy level. 3, 4, 5, 6. Carbon is done.
Fun fact.
Electrons determine how big the atom is, but the nucleus determines what the mass of the atom is. Also, this is a model called the Bohr model. In real life, these electrons are actually spaced all around, almost like onion rings around this nucleus, and it isn't as flat as this, and they also don't move like planets. It looks like these shown like they should move like planets, but they don't.
Well, that concludes our lesson about the Bohr model and atoms today. Bye!